Hello viewers, today we're going to cover a little bit about how to identify different types of graphs. So if you're wondering why I have my stuff written down already, I actually recorded this video, but I forgot to turn on my microphone, so it ended up not recording my audio. Silly me. But anyways, we're just going to run this through real quick. So first off, we're going to start off with linear graphs. So linear graphs either have an x to the power of 0 or x to the power of 1, something like that on the way. So yeah, let's take a look at this. So some example of linear graphs, the equations are like y equals to 2x plus 3, x equals to 2y minus 4, x equals to 5, or y equals to negative 2. So yeah, these are some examples of linear graphs. But how do they look like? Like, what do they look like? So they can either, they're just basically straight lines. So they can either be vertical, horizontal, or oblique. Yeah. So we need to learn what are linear functions too, which are usually denoted by y equals to mx plus c. So, or you can just write this as a function. Yeah. So c will be the y-intercept, where the graph will intercept the y-axis, and m is the gradient. So what is a gradient? The gradient is basically the rise over the run, which is the difference in the y values over the distance of the x values. So gradients, they can come in four different types. You can have a positive gradient, which will look something upwards. So just imagine you're a person trying to make progress. So if progress is positive, you're moving upwards. Then you have a negative gradient, which is just going down this way. So if you're a person and you're going through hard times, that will be seen as negative. So therefore, you're just like hindering yourself. And we can also have horizontal gradients, which will equal to 0. So if you're a person and you're just moving in a straight line, you're not really making progress or improving, so you're just stagnant. And we all know that success doesn't come overnight, so you cannot immediately jump from one point to another. So therefore, for vertical lines, gradients will be undefined. So what do linear graphs look like? They can look something like this. So for this one, I let my graph be y equals to 2x plus 1. Okay, and for my other one, I let my graph be y equals to negative 2x plus 1. So for both of them, we can understand that the y-intercept will be at coordinates 0 to 1. And for this one here, our gradient will be 2. But then for this one, our gradient will be negative 2. So on the graph, it will cut through at the y-axis at 1. And since the gradient is 2, that means it's a positive. So it will go up like that. For this one, same thing, but the gradient is negative 2, which is a negative gradient, so therefore going down. These are just inverses of each other. So what about graphs for x equals to 5 or y equals to negative 2? So let me just draw out my axes real quick. So for cases like x equals to 5, it will just be a vertical line that cuts through the x-axis at 5, 0. Yeah. And as for y equals to negative 2, it will just be an horizontal line that cuts through the y-axis. Oops, that's not horizontal. Okay, yeah. It will just be a horizontal line that cuts through the y-axis at the point 0, negative 2. Yeah? So these are also considered linear graphs, but they are not considered linear functions. These are considered linear functions, but these are not. Alright, moving on. Now we have to focus a little bit on quadratic graphs. So quadratic graphs are basically graphs that have x to the power of 2. Okay? So they can look like that. They basically just look like U shapes. They can come in many different shapes and sizes. They can be located differently from one another. So you can write this as ax squared plus bx plus c equals to y, where c is your y-intercept, once again, and a will determine how your graph looks like. So if a is a positive value, then your graph will look like this, a U shape. If a is a negative value, then your graph will look like a inverted U. So why is that so? So if a is positive, your graph will be like that, right? So just imagine yourself being happy. Hold on. So just imagine if you're making progress, if you're positive, you'll be happy, right? Now I just want you to look at the mouth. Same shape as the graph. But then for this one, if your a is negative, your graph will look like an inverted U. So therefore, if you're negative, you'll be sad. And take a look at the mouth. Same shape. Alright. So that's how you can identify quadratic graphs. Just a U. As for cubics are basically x to the power of 3. And they can be written as ax cubed plus bx squared plus cx plus d equals to y, where d this time is your y-intercept. Now, your a will determine what shape your graph will look like. So when a is a positive value, your graph will look like this. When a is a negative value, it will just be an inverse of that. So for example, this is just a random sketch. It's not drawn to scale. If a equals to 1, it'll look something like that. But then if a equals to -1, then it'll just be the inverse. Remember. And for the last 3 graphs, I'm going to do x to the power -1, x to the power -2, and exponential graphs, which I did cover an exponential function in another video, but you can watch that after this one. So ax to the power -1, you can write this as a over x to the power 1. So they can either look like the red one, or they can look like the green one. And as you can see, there are these points over here which approaches the axis, but they never touch. These points are what we call asymptotes. And if you're wondering why they don't touch the axis at 0, that is because if I let x equals to 0, then I'm going to get a over 0. And we know that we cannot divide a number by 0, so therefore that's why. So if a is a positive value, then my graph will look something like that. So if a equals to a negative value, like you guessed it, an inverse of the positive one. Now if we move on to -2, same as before, if I let x equals to 0, then I'll get a over x 0 squared, which will give me a over 0, which therefore that's a no. So yeah, they have asymptotes too. So if a is a positive value for ax to the power -2, it will look like this. I like to remember this as a butt graph, because it looks like a butt cheek. And if a is a negative value, that will just be an inverse of the positive one. Alright, remember that. And lastly, we move on to exponential graphs. So exponential graphs can be written as y equals to k times a to the power of x, where there are a few rules to be observed here. A can either be more than 1, or a can be more than 0 but lesser than 1, and a cannot equal to 1. Okay, why is that so? I'll show you. So in this graph, if I let a equal to 1, I'll get y equals to k times 1 to the power of x. And we know that 1 to the power of anything is just 1 itself. So therefore, I will get y equals to k, which is technically a linear graph, not an exponential. So therefore, a cannot equal to 1. Alright, so yeah, moving on. K kinds of determine which point you will intersect on the y-axis. Yeah, so I'll show you later on. So for all my graphs today, I'm going to let k equal to 1. Okay? For these two for now. So for here, I'm going to let my a equal to 2. And since 2 is more than 1, my graph will be an exponential graph. And it will be denoted by y equals to 2 to the power of x. So since my k equals to 1, it will cut through the y-axis at 1. And it's an exponential graph. Yeah? Now, if I let, this is a different one. If I let a equals to 0.5, that will mean that my graph will equal to y equals to 0.5 to the power of x. Okay, so same thing as before. We had to identify 0.5 is in between 1 and 0. So therefore, it will be an exponential decay. So it'll look something like this, and same as before, since my k is 1, it'll cut through the y-axis at 1. Alright? Okay, so now what if I let my k equal to -1? If I let my k equals to -1, then it's just going to be an inverse of the tops here. So I'm just going to let my a values remain the same. So a equals to 2, since my k equals to -1, I'm going to get y equals to -1 times 2 to the power of x. Yeah, something like that. So since my a is still more than 1, it's going to be exponential growth. But because of the k value, it ends up making it an inverse. And an inverse is just an opposite, so it therefore looks something like that. So yeah, it will cut through the y-axis at -1. Okay? And as for this one, I will still get y equals to negative 1 times 0.5 to the power of x. And because of my a value, it will be an exponential decay. But because of my k value, it will be an inverse of the original one over here. So therefore, it will look something like that. Yep. And as you can see, it cuts through the y-axis at -1. Alright, so that does it for today's video. I hope these tips can help you identify the different type of graphs better. So, goodbye.